All right, 1-5 pre-calculus, analyzing graphs of functions. Just making sure the pen's working. So we're going to take a look at a few different types of graphs today. So first thing, let's take a look at this first one. Let's talk about domain, which we've talked about, and then function values and range, which we haven't yet. So in this one, the domain, remember that's all of the inputs that we can use. So in this case, we're trying to find all of the x values. So in this graph, it starts over here and goes to over here if we're talking about side to side. So the most left point is x is -1, and the most right point is x is 5. So on this one, for answer A, we would say that for the domain, we have -1 is less than or equal to x is less than or equal to 5. Just all the different numbers that x could be. All right, second question, B, says f of -1. So what we're going to do is we're going to say, okay, what's the y value, right? So f is saying what's the y value if x is -1, right? So I'm going to go find x is -1 right here. What's the corresponding y value? Okay, so if x is -1, we're going to say y is 1. So for answer B, f of -1 matches up with a y value of 1. We're going to do the same thing here. If x is 2, which is, here, if x is 2, then what's our y value? Our y value would be -3. So f of 2 equals -3. And then C, what's the range? All right, so the range here is y values. And in my mind, I've always remembered that domain and range, alphabetically, D comes before R, X comes before Y in the alphabet. So domain with X, range with Y. So we'll take a look here. We're going to find the lowest point. Okay, the lowest point here is -3. The highest point up here is +3. Less than or equal to 3. And so that would be our range, and we would write it the same way. Range runs from -3 to 3. So that's the answer. All right, so see if you can come up with your answers the same way on exercise 9. All right, so vertical line test, we have talked about this a lot. I think you pretty much understand it. To be a function, you need to pass the vertical line test. So this one does not. This one does. Okay? And on this one, it seems like it passes the vertical line test. Okay? However, right here, we're missing something. So the question is, what happens if there's a spot where we're missing something? Can we jump? Okay, so let's look back at the definition. Vertical line test, a set of points in a coordinate plane is the graph of y as a function of x if and only if no vertical line intersects the graph at more than one point. Okay, so in this case, we're okay. Still a function. So see if you can figure out if exercise 17 is or is not a function. All right, zeros of a function. When we talk about zeros of a function, we're talking about f of x equals 0, which we all know means when y is 0. And the other way to talk about that is when we cross the x-axis. So we're trying to find all the places we cross the x-axis. All right? So those are the zeros of a function. So let's look at an example here. Find the zeros of each function. To do these, we're just going to set y equal to 0. And then see if we can solve for x. So 3x squared plus x minus 10. We're going to factor this. So I know I've got a 3. I know I've got a 1. Let's see. What are some factors of 10? Either 10 and 1 or 5 and 2. And let's see. What if I did 5 and 2? That should work because that's 5. And on the other side, 3 times 2 is going to be 6. And I want a positive one, so this has got to be a plus. that's got to be a minus. So plus and minus. And so that's factored. And so now we can set each of those equal to 0. 3x minus 5 equals 0. So x equals 5/3. And x plus 2 equals 0. X equals negative 2. Okay, so we're going to do the same thing for b. 0 equals the square root of 10 minus x squared. How would we get rid of the square root? Square it. So we've got 0 equals 10 minus x squared. Bring the x to the other side. X squared equals 10. X equals plus or minus root 10 on this one. Okay? All right, and for c, erase these. For c, 0 equals, 2, not h. 2t minus 3 over t plus 5. Okay, so we can't have a 0 in the denominator or in the numerator here, so we're going to say 2t minus 3 equals 0. So t equals 3 halves. And in the denominator here, we're going to say t plus 5 cannot equal 0. T cannot equal negative 5. We're going to have a restriction on this one. So this is a restriction, something we can't be. And this is going to be a 0, a place where we cross the y-axis. All right? Go ahead and try exercise 23. Okay, so let's talk about increasing and decreasing functions. And so what this is saying is we want to be able to look at a graph. Let me bring one up here. And if it just goes like this. Okay? We want to say from what point to what point are our y values going up if we read like we read a book going from left to right. So reading this way, if we were tracing our pen across the graph, we would be increasing, going up, 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 up to here. So from here to here, we are increasing. Okay? Then all of a sudden we turn around and dot, 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 tracing down. From here to here, we are decreasing. We're going to turn around and go up, 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 up. Here we're increasing, down, 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 decreasing, and finally, forever and ever, to infinity, we're going to be increasing. All right, and so we're going to want to tell the x values of those points. Okay? So let's take a look here at these graphs. Describe the increasing or decreasing behavior of each function. All right, so for this first one, we are increasing. And I'm just going to use an up arrow there. You can as well. We're increasing from negative infinity to infinity. All right? I'm going to use parentheses. Parentheses mean less than and greater than, meaning we can't touch it. Okay, we're not going to get to it. Well, on this one, we're increasing from negative infinity, and then we stop increasing right here. So that x value there is negative 1. Then we start to decrease. We're decreasing from negative 1 to this point, to positive 1. And then we're increasing again all the way forever and ever. So from 1 to infinity, we're going to be increasing. All right, last one here, we're increasing from negative infinity to right here, which is 0. We are constant from 0 to 2, meaning we're not going up or going down. And we're decreasing then from 2 to infinity. All right, so that's the concept. See if you can do exercise 41. All right, so same thought process as we just went with increasing and decreasing, works with minimum and relative maximum. We're talking about where things are going up and down. But here, instead of the range of where things are going up, I want to know where's the peaks and where's the bottom of the valleys. Okay? So these 2 points are what we call relative maximums. Okay? They're not absolute maximums because only one of them, this one here, is the absolute highest point on the graph. So this one's an absolute max. But both of these points are relative maxes because around them, they're the highest point. They're the peaks. So then the relative minimums are going to be these points, with this point here being the absolute minimum. Okay? So let's see if we can use this on example 5. So use a graphing utility to approximate the relative minimum of the function given by this. Let me jump over to the graphing calculator and throw this into our y equals. Let me clear this out. And so we've got 3x squared minus 4x minus 2. Okay, and I'm going to go ahead into my window and give myself an appropriate guess. Negative 10 to 10 is what we're going to guess if we're not sure where to start. And go ahead and graph it. And we've got things going like this. And I'm going to, right now, if I'm looking at this, notice that just right here, I just have one relative minimum going on here. All right, so I want to know where that point is, and so I'm going to trace it. And I'm looking at my y values. They're going down, looks like negative 3.3, 3.2. Yep, I'm heading back up. So somewhere right around 3.3 is going to be my relative minimum. I think I'd really want to be a little closer in, so I'm going to hit the zoom box and make a little box around this relative minimum. And now when I use my trace feature, I'm really going to be able to zoom in on this thing. So I hit trace, I'm on the curve. 328, 329, 331, 331, 332, 333. And now we're heading back the other direction. So it looks like negative 3.33 would be our lowest point on this one. Okay? And so we would say 0.67 comma negative 3.3 is our relative minimum. Back to our PowerPoint. Oh, looks like it's freezing. I'm going to pause the video just for a second. All right, so let's try exercise 57. Try to find the relative minimum and maximums if they ask for it. All right, so let's talk about average rate of change. All right, so we know that slope is this, y2 minus y1 over x2 minus x1. That's our slope. All right, so up to now, we've just figured out the slope of straight lines, right? From one point to another in a straight line. All right, so the average rate of change, though, is we're going to say, okay, what if we have a nice little curve? We started here and ended here, right? Well, we're steeper up here than we are down here, right? So we don't really have a consistent slope throughout the whole thing. What we're going to figure out is just the average rate of change. We're going to create a straight line just connecting those 2 points and find the slope of that. All right, so it's just the slope, same way we've done it, but in this case, we're kind of creating the straight line. And this straight line, you can see here, is called the secant line. Okay, just connecting 2 points. So let's find the average rate of change for this formula from x1 is negative 2 to x2 equals 0. And then we'll try it again for problem B. All right, so x1 equals negative 2, x2 equals 0. The problem here is I don't know what my y1s and my y2s are. So we're going to have to plug them into our equation. So let's go ahead and plug this in. This is negative 2 cubed minus 3 times negative 2. And so that's negative 8 plus 6, which is negative 2. And then same thing, plugging in 0. 0 cubed minus 3 times 0. That one's nice and easy. That's a 0. Okay? So now we can figure out our slope, our rate of change. And so this is -2, the y value, minus -2, the x value, okay, over 0 minus 0. So on this one, oh, I apologize. That wasn't looking right, and I see my mistake. I was trying to put x's with y's here. Let's try that again. My y1 is -2 minus 0 is my other y value. Sorry about that. Matches up with -2 minus 0 over here. So -2 over -2, which is 1. So we do have an average rate of change, and the slope would be 1. Okay? All right, so we'll go ahead and do it from 0 to 1. So I'm not going to redo the 0 line. We already know if I plug in 0 for x, what I get for y. So let's just change the other x value. So here we go. We've got x1. So sorry, x1 is 0. So let's just change that. We'll make this x1. And we'll make this x2 is 1. Let's go ahead and plug it in for, this will be y1, and this will be y2. And so here we go. 1 cubed minus 3 times 1. And that's 1 minus 3, and that's -2. So we'll go ahead and find our new slope. So for our y values, we've got -2 minus 0, which is -2. And for our x values, we've got 1 minus 0, which is 1. So our average rate of change now is -2. Okay? Notice that these are coming from the same equation, same graph. So we change places on the graph, we get different slopes. See if you can do it for exercise 75. All right, 2 examples to go. Let's try the word problems. The distance s in feet a moving car is from a stoplight is given by this function. Find the average speed of the car from 0 to 4 and from 4 to 9. All right, same exact thing as we just did here. I'm going to make a quick t-table here. That might just help us just a little bit, and it's going to relate time to speed. And the important points we've got here are 0, 4, and 9. Go ahead and plug these things into this. 0 to the 3 halves is still 0 times 20 is 0. 4 to the 3 halves is going to be 8. 8 times 20 is 160. And 9 to the 3 halves is going to be 3 cubed is 27 times 2 is 540. Okay, so those are going to be our different values. And so now we can find our rate of change. For the first one, for A, m equals, let's plug in our y's, 160 minus 0 over 4 minus 0, which gives us 160 over 4, which gives us a rate of change of 40. All right. So in the first 4 seconds, we're increasing at 40. I guess this is feet per seconds. Yeah, feet per second. And for part B, our slope is 540 minus 160 over 9 minus 4. And so the top here is going to be 440 minus 60 is 380, all divided by 5. And if you do 380 divided by 5, you get 76 for our slope. See if you can do it. 113. All right, last thing, even and odd functions. All an even and odd function is saying is that even is the same thing as saying y-axis symmetry. We've talked about this in detail. Remember, even makes sense because we said y-axis symmetry, graphs with x squared. Odd is the same thing as saying origin. We talked about x cubed. All right, so I'm just going to jump right into these because I think we should be able to do this. The function x cubed minus x is odd because of the following. Remember, we're going to plug in negative x. And we're going to plug in negative y. Okay, so negative g of x, which is the same as saying y. And let's see what happens. Negative, I'm just going to write y right here. It's a little easier to write. That becomes negative x cubed, and that becomes plus x. And so to get it back to normal, we're going to divide by negative 1. And look at what we got. Y equals x cubed minus x, right back where we started. So this is odd. Okay, x squared plus 1 is even. Same thing, remember, we're going to say y equals, for even, we check for just negative x. And what happens when you square a negative? It turns right back into a positive, and we're right back where we started. Last one, see if you can figure out odd or even on these. Oh, sorry, one last thing before we do that. Symmetric to the origin, just a reminder there, it spins around the origin point, and symmetric with the y-axis, you can have it flipped over the y-axis. Exercise 83 wraps you up for tonight.